Okay, so hi and welcome to your lecture 5 of the topic clutch. Okay. So today we are going to see in detail about the multi-plate clutches. Okay, so we will detail about the multi-plate clutches. Okay, so നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ about the single plate clutch. അതിന്റെ basic equations, torque transmission equations, രണ്ട് cases ഉണ്ട്. When the clutch is new and the second case was when the clutch becomes older. Okay, so ആദ്യത്തെ യൂണിഫോം പ്രഷർ കണ്ടീഷൻ ആയിരുന്നു, രണ്ടാമത്തെ യൂണിഫോം വെയർ കണ്ടീഷൻ ആയിരുന്നു. അപ്പൊ രണ്ടിന്റെ ഡിഫറെന്റ് ടോർക്ക് ട്രാൻസ്മിഷൻ ഇക്വേഷൻ ആണ്, രണ്ടിന്റെയും എഫക്റ്റീവ് റേഡിയസ് ഡിഫറെന്റ് ആണ്. അതുപോലെ രണ്ടിന്റെയും ആക്സിയൽ ലോഡ് ഡിഫറെന്റ് ആണ്. അതേപോലെ യൂണിഫോം വെയർ കണ്ടീഷന്റെ കേസിൽ എക്സ്പീരിയൻസ് മാക്സിമം pressure and how to find those different things we have already seen. Right? So, in the case of multi-plate clutch, in the case of this in detail, see what is the basic difference between a single plate clutch and the multi-plate clutch. Okay, so we'll start this with. I'll show you a video on how does a multi-plate clutch work. Okay. So, okay, so this is from YouTube. Okay, so what's this video? Let's start once again. Okay, so assume that it is clear, but still to make it more clear, let me play it once again and I'll explain in between what it is. Okay, so okay, so here they are actually showing the basic conventional type of a clutch, right? So which is a single plate clutch, which can be seen in most of the automobiles like cars, trucks, and all, right? So it is having as a single plate and there are two friction surfaces. Okay, we have also already seen the different problems as well, right? The two surfaces are having are having friction surface. That is, the effective surface is 2, right? We have taken n equal to 2 because the two surfaces are having friction. Both are friction surface. Okay. So this is the basic thing, or the single plate. Okay. Okay. Now, unlike the single plate cleanse, for a multi-place test, we'll be having number of plates. Okay, as you can see from here, there are number of plates. Okay, so these are actually called the driven, the driving plates. Okay, these are the driving plates, and uh, so we have, instead of a single plate, the main difference is that instead of a single plate, you will have number of series of plates. Series of plate with friction surface, as you can see in the figure. Okay, okay. Now this friction disk is connected to a shaft in between. Okay, you can see the engagement, how it is engaged. You can see the kind of a surface over here. Right, so it is engaged in this fashion. And now, so these the first part, the first set of plates is actually your uh, your your friction disk or the driving plate. Okay. Now, now you can see that steel discs are used in between, right? So to engage this one, actually you need a driven plate as well, right? You have a driver as well as a driven. Okay. So the these pieces which are having, so as you can see, this one, these are the driver. Okay, and it is having friction surface attached to this one, right? So the plates are having friction surface, and this is actually to increase the coefficient of friction, right? Now, ടു എൻഗേജ് ദിസ് വൺ, നമ്മൾ ഇതിനെ എൻഗേജ് ചെയ്യണമെങ്കിൽ നമുക്ക് ഒരു സെറ്റ് ഓഫ് പ്ലേറ്റ് കൂടെ വേണം അല്ലെ. അപ്പൊ ഇതിന്റെ ഗ്യാപ്പിൽ നോക്കിക്കഴിഞ്ഞാൽ ഓരോന്നിന്റെ ഗ്യാപ്പിൽ വിൽ ഇൻസേർട്ട് സം സ്റ്റീൽ പ്ലേറ്റ്സ്, അതിനാണ് ഡ്രിവൺ പ്ലേറ്റ്സ്. ഓക്കെ, ഇറ്റ് ഈസ് ഇൻസേർട്ടഡ് ഇൻ ദിസ് ഫാഷൻ. ഓക്കെ, നൗ യു ക്യാൻ സീ സെറ്റ് ഓഫ് സ്റ്റീൽ ഡിസ്ക് ആണ്. ഓക്കെ, സോ ഈ സ്റ്റീൽ ഡിസ്ക് അല്ല, ഇതിന്റെ ഇൻ ബിറ്റ്വീനിൽ നമ്മളെ ഇതിന്റെ ഗ്യാപ്പിൽ കംപ്ലീറ്റ് സ്റ്റീൽ ഡിസ്കിനെ പ്ലേസ് ചെയ്യും. ഓക്കെ, now you can see the steel disc is having a peculiar design, right? So a gap is there, and another projection, again a gap is there and a projection and all. Okay, so you can see why it is used. Okay, now this is connected to a casing. Okay, you can see this one, right? So it is connected to a casing, right? That gap is for connecting this outer structure. Okay, so why do you need this one? Because this is actually okay, this steel shaft, which is the driven shaft, driven disc. Okay, so this is actually transferring the motion to the casing. Okay. Okay, so ഇത് നമ്മൾ പ്രഷർ അപ്ലൈ ചെയ്യുമ്പോൾ അതിലുണ്ടാകുന്ന ഡിസെൻഗേജ്ഡ് പൊസിഷൻ ആണ്. ഓക്കെ, സോ ഡിസെൻഗേജ്ഡ് പൊസിഷൻ നമുക്ക് കാണാം. അത് ഫസ്റ്റ് ഇൻസേർട്ട് പാർട്ട് മാത്രമാണ് റൊട്ടേറ്റ് ചെയ്യുന്നത്. ഓക്കെ, വിത്ത് ഫ്രിക്ഷൻ ലൈനിങ് ഉള്ള പാർട്ടാണ് റൊട്ടേറ്റ് ചെയ്യുന്നത്. ഓക്കെ, വെൻ ദാറ്റ് ഇസ് then that becomes engaged. ഓക്കെ, വെൻ നമ്മൾ കൊടുക്കുന്ന പ്രഷർ ലീവ് ചെയ്ത് കഴിഞ്ഞാൽ അത് എൻഗേജ്ഡ് ആകുമ്പോൾ ദാറ്റ് റൊട്ടേറ്റ്സ് ആസ് എ സിംഗിൾ യൂണിറ്റ്. ഓക്കെ, നൗ so you can see it is rotating as a single unit. Okay, so the pressure is actually applied using this coil springs. Okay, and you have a pressure plate. Now this motion is actually possible because there's a push rod. Okay, you can see a push rod is in between, which is facilitating this motion to happen. Okay, so you have series of springs and a push rod to make this mechanism happen. Okay, so so you can see this is the engaged position, this is the engaged position, and this one is the disengaged position. Okay, so now you can see how the motion gets transferred. Okay, so now you can see the steel plates. Okay, so you can see how this works. Now this is in the disengaged position. Okay, so it is rotating freely. Now you can see, right? and the push rod moves up. So what happens is it becomes engaged and then the rotation happens. Okay. So that's it. That is a basic working of a multi-plate clutch. Okay. So effective when you see this one, when you see this topic of multi-plate clutches, the main difference is that instead of a single plate, as you have seen in the single plate clutch, there are number of plates. Okay, so what are these plates? You have this uh, this this plates, right? You have the clutch plates with friction surface, and in between you have steel plates, right? You have steel plates in between, right? So when that gets engaged, the motion will be transferred to this one, and then it is transferred to the uh, next portion, and then it continues, right? Now, so basically, when you so why are this? When the obvious question is why is multiplate clutch used, or what are the basic advantages of using a multiplate clutch? Okay, so as the multiplate clutches are made up of more clutch plates, okay, more clutch plates, the capacity of transmission of torque is quite high. Okay, so you can actually transfer a higher torque. Okay, not only higher torque, and this complete setup can be set up in a limited space. Okay, that is a very important thing. Limited space. You require only a small space to transfer this higher torque. That is the main advantage of using a multiplate clutch. Okay, higher torque can be transmitted. And it can be employed in a very small space. Okay, so this type, that is the next advantage you can see over here, that this type of clutch is small in size, and because of this you can use it in small vehicles like your two-wheelers and all, right? So it requires only small space. Now unlike this one, for a single plate clutch, to transfer high torque, actually you require a very huge clutch plate, right? Okay. Now, in comparison with a single plate, the diameter of the multi-plate clutch is much smaller than the single plate clutch, and that makes it possible to use it in uh, this one for two-wheelers, and for your this one racing cars and all. This multi-plate clutch system is used. Okay. So the basic difference between a single plate clutch and a multi-plate clutch is all the basic equations are almost same. Only thing is that the number of we have seen that the torque transmission T is nothing but N mu W into RF is the general equation. Okay. Even this is having two types of conditions, that is pressure, uniform pressure, and uniform wear condition. Okay, uniform wear condition is applicable to these as well. But the thing is, the only difference is that the number of contact surface is different. Okay, so the number of contact surface, or the number of, where n is the number of effective surfaces, number of effective contact surface. Okay, contact surfaces. Okay. So to find this one, n is equal to n1 plus n2 minus 1 is the equation. This is only change for a multiplied class. Okay. Now where your n1 is the number of driving plates, and n2 is the number of driven plates. Okay. So that's it. So our n1 is the number of driving plate, and n2 is the number of driven plates. So to get the number of effective surface, all you have to do is add these two and subtract one. Okay, and remaining things are same. Okay, so we'll see that using a problem. Okay, using an example problem, we'll establish that relationship. Okay, we'll see this one. Okay, so please note down this problem of the multiplate test. Okay. A multiplate clutch has 5 plates. We'll say, take a different problem. Okay. A multi-disc plate has 3 discs. A multi-disc clutch has clutch has three discs on the driving shaft on the and two on the driven shaft on the driven shaft. The inside diameter of the contact surface is inside diameter of the contact surface is 120 mm. The maximum pressure between the surface is limited to the maximum pressure between the surfaces is limited to 0.1 Newton per mm square. Design the clutch for transmitting design the clutch for transmitting 25 kilowatts at 1575 rpm. Assume uniform wear condition. Assume uniform wear condition and coefficient of friction as 0.3. Okay, so we'll solve this problem using this condition. Okay, so so you have a multi-disc clutch which is having three discs on the driving shaft and two on the driven shaft. The inside diameter of the contact surface is 120 mm. The mass surface is limited to 0.1 Newton per mm square. Design the clutch for transmitting 25 kilowatt at 1575 rpm. Okay, so effectively all you need to find is the inner radius. Okay, so first of all go through the question properly and then uh, start solving. I'll give you some 2-3 minutes to go through the question and then we'll attempt the question. So you can pause the video and just analyze this question. Okay, so I hope you have gone through the question and you might have started attending the question. So you may check this once while we are solving this one. Okay, so effectively എനിക്ക് തോന്നുന്നു നിങ്ങൾക്ക് എന്താണെങ്കിലും മിസ്സിംഗ് ഡാറ്റ എന്താണ് കണ്ടുപിടിക്കണമെന്ന് മനസ്സിലായിട്ടുണ്ടാവും വിചാരിക്കുന്നു. Okay, so you have a multi-disc plate clutch. Okay, so the question is all about the multi-disc plate which has three discs on the driving shaft. Therefore, your N1 is equal to 3. Now, similarly, your N2 value is 2 and 2 on the driven shaft, N2 value is 2. Okay. The inside diameter of the contact surface, inside diameter, so that is D2 or is equal to 120 mm. So from this you can say that your R2 is 60 mm. Okay, so since we are dealing with mostly the radius, okay, so all our equations are based on the radius, right? The maximum pressure between the surfaces is limited to 0.1 Newton per mm square. Okay, so your maximum pressure is equal to 0.1 Newton per mm square. Okay. Design the clutch for transmitting. So the power to be transmitted is 25 kilowatt at an RPM of 1575 RPM. Okay. Speed of 1575 RPM. Assume uniform wear condition and take the coefficient of friction mu is equal to 0.3 and you can assume uniform wear condition. So you are asked to design the clutch. Okay. നമുക്ക് ഇവിടെ നോക്കിക്കഴിഞ്ഞാൽ നമുക്ക് ബാക്കി വാല്യൂസ് തന്നിട്ടുണ്ട്, ഡയമീറ്റർ തന്നിട്ടുണ്ട്, അല്ലെങ്കിൽ ഔട്ടർ റേഡിയസ് തന്നിട്ടുണ്ട്, പൊസിഷൻ ഓഫ് ഫ്രിക്ഷൻ തന്നിട്ടുണ്ട്, മാക്സിമം പ്രഷർ താങ്ങാൻ പറ്റുന്ന തന്നിട്ടുണ്ട്, ക്ലച്ചിന്റെ എണ്ണം തന്നിട്ടുണ്ട്. അപ്പൊ ഇനി മെയിൻ ആയിട്ട് ഇവിടെ കണ്ടുപിടിക്കുന്നത് എന്താ, അതിന്റെ ഔട്ടർ ഡയമീറ്റർ ആണ് അല്ലെ. സോ ഓൾ യു നീഡ് ടു ഫൈൻഡ് ഈസ് D1 or R1. Okay, R1. Okay, now how do we find that? അപ്പോൾ ആ കൂടെ ഒരു unknown value ആണ് അവിടെ വരുന്നത്, right? Now, so again, you are asked to use uniform wear condition and the basic equation, the end equation is your torque is given by, or torque transmitted is given by mu W RF, right? Now, here, let us check whether all these data are given or not. Okay. So to complete this one, your coefficient of friction value, yes, it is given, mu value is given, but axial load value, it is not given, and RF value also, it is not given, you have to find it out. Torque value, it is also not given, you have to find from this equation. So we'll start with the torque. Okay. So for the torque transmitted, you can start with your torque transmitted. T can also be found using P into 60 divided by 2 pi n equation. Okay. So substituting the values, it is 25 into 10 cube into 60 divided by 2 into pi into RPM. RPM n is 1575 RPM. Okay, 1575 RPM. Okay. So upon solving this one, you will get the value as uh, 151.6 Newton meter. 151.6 Newton meter, or that is equal to 151600 Newton millimeter. Okay. Now, so your torque value, yes, now your torque is completed, coefficient of friction is completed. Now you have to represent, you have to find this axial load, right? So the axial load W is equal to, we know that the equation is 2 pi C into R1 minus R2. Okay, for the uniform wear condition. Correct. Now here, the problem is you have two unknowns. C is an unknown. Again, your radius R1 is an unknown. Okay, so it is difficult to continue with this. Now, so if you can find any one of this one, okay, for example, if you can find the value for C, then this becomes a single unknown equation, right? So we can make it like that now. So we have a condition called your maximum pressure is given. Okay. Now we know that your P max into R2 is nothing but C. Right. So P max, we know the P max value, and R2 value is also given in the question. Okay. So you can find the C using that relationship, which is P max is 0.1 into your R2 is 60 is equal to C, or your C is nothing but 6. Okay. Now, therefore, your axial load W becomes 12 pi into R1 minus R2. R1 you don't know, minus R2 is 60. Okay. Right. So we have represented W in terms of R1. Right. Now, your RF value, RF is nothing but R1 plus R2 divided by 2. So that is equal to R1 value you don't know plus 6. So substituting these values, for example, let this be my first equation, let this be second, third, and substituting 2, 3, and 4. Okay, substituting 2, 3, and 4 in 1. And the torque equation in the 151600, right? 151600. 1600 is equal to 151600 is equal to mu into equal to, sorry, it is not just mu, n times, right? N mu WRF, right? So you have to multiply with the n. Okay. Now the n value you can find it from here. N is equal to n1 plus n2 minus 1. Okay, so that is equal to 3 plus 2 minus 1, which is equal to 4. Okay, so n is the number of effective surface for a multiplied flux. Okay, so that is equal to 4 into mu into W value we have found out 12 pi into R1 minus 60. 12 pi into R1 minus 60 into R1 R1 minus 60 R1 plus 60 divided by 2. Right. Okay, cancel this one. This becomes 2 times. Okay, okay. So this becomes 2 mu into 12 pi into R1 square minus 60 square, which is equal to 151600. Okay. Now the mu value is given, and all the remaining values you know. Just substitute these values and find the value of R1. Okay. Now if you substitute those values, you will get the value of the radius R1 as 101.5. Okay, so that's it. So the only difference when compared to the single plate clutch is that you need to find the uh, effective number of discs, which is actually the sum of uh, number of discs in the driver plus number of discs in the driven subtracted with one. Okay. So that's it. That is the problem. Okay. Now, uh, so every other problem you can practice the remaining problems for a multi-disc plate clutch. Okay. Every other problem is same. The concept is same. There will be some small twist and all related to the P max value. Maybe sometimes you will be given some P minimum value and all. So that's it. So mostly you will be asked to find using the uniform air conditioning. If nothing is given, you can actually take the assume it to be your maximum air condition. Okay. So that's it. That's it for the day. Okay. So if you want, you can practice one problem. I'll write down the problem. Okay. So this is going to be your next assignment as well. Okay. So the problem. Okay. So you can write the problem. A multiple disc clutch has 5 plates. Five plates having 4 pairs of active friction surfaces. If the intensity of pressure is not to exceed 0.127 Newton per mm square, find the power transmitted find the power transmitted at 500 rpm. The outer and inner radii of friction surfaces are 125 mm and 75 mm respectively. Assume uniform wear and take coefficient of friction mu as 0.3. Okay, so a multi-disc plus having five plates having four pairs of active friction surfaces. If the intensity of pressure is not to exceed 0.127, find the power transmitted at 500 rpm. Okay, so you have to find the power transmitted. Okay, so to find the power transmitted, first of all you will have to find the torque transmitted. Okay, now the outer and inner radius of friction surfaces are 125 mm and 75 mm respectively. Assume uniform wear and take coefficient of friction as 0.3. Every data is given, you can directly solve the problem. That's it. Okay. Okay, so thank you. We'll meet again. Okay. So the next topic is cone clutch. So the next class we'll be completing the cone clutch and followed by centrifugal clutch. That's it. So with this, the four types of clutches will come to an end. So we require maximum two more classes to complete the clutch topic. Okay. After that, you have the topic of brake. Okay. Again, that is lengthy. Your first module, your topic, there are a number of topics. Even though the topics are simple, you have a number of topics. So first module will take quite a few time. And, when it comes to a second module, you won't require that much time, so it can be completed for in a in a in a fast I mean can be completed easily. Okay, with very short duration. So thank you.